Yeah, absolutely. So my name is Meike. I'm here with Ornagh, and yeah, the two of us work for Aspect Structural Engineers. We're a design firm based out of, our headquarters is in Vancouver, and we were founded in 2016 by 5 partners. And since then, we've grown into a handful of offices now. So we've got our headquarters in Vancouver. We're also located in Toronto. We have another office in Bern in Switzerland. And then our fourth office, which we just announced, is in Seattle. So we're really excited about that. But yeah, we're a design firm made up of about 60 engineers now. And we work in all main material types, but we're really passionate about mass timber design, but also do steel and concrete design. Yeah. And then my background is I actually started as an intern at Aspect back in 2018. So I did an internship here. After that, I did an internship at Structurlam, which was a major mass timber fabricator based out of British Columbia here. And then after my graduation, I joined Aspect full-time, and I've been here ever since. Yeah.
Okay. My name is Ornagh. I am Irish, so from Ireland, and that's where I studied. I went to Trinity College there. I did do 1 semester in Milan, and then did a internship with Hilti in Liechtenstein before returning to Dublin to finish my studies. And then when I graduated, I moved to London and worked predominantly in retail and leisure projects, mostly steel construction. And then 4 years ago, I moved to Vancouver and joined the Aspect team. And yeah, really got into mass timber design from then.
Great. And Aspect's definitely got a tier 1 brand globally. And I know you've been a part of as a company, some amazing projects. So can you start by telling us a little bit about what projects the team's been part of, and also the ones that you've been contributing to, and that'll get us back into the rest of the topic where we'll talk about tall buildings.
For sure.
Yeah, sure. So one of our more notable projects is Tallwood 1, which is on Vancouver Island in Langford. It's in a really high seismic region. It was the first tallwood construction to the new encapsulated mass timber code, which came out. It's a 12-story point-supported CLT on glulam columns with EBF brace frames. And that finished construction in 2022. We've also got a number of other projects in design, a couple in Seattle, one 17-story, which is 12 stories of mass timber on 5 stories of concrete. And that's sort of in the early construction document stage. And then, just a couple more residential in tall timber, and a lot of like hybrid systems. We're seeing, especially for the multifamily, up to 5-6 stories, CLT floors on lightwood frame walls is a really good construction type. So we have quite a few of those projects as well.
Yeah, and then we've got some kind of unique projects as well, including like the Malahat Skywalk project, which is also on Vancouver Island. It's kind of a cool tourist attraction, a nice skywalk that you can go visit. And then we have a lot of like custom home projects. And we also do temporary works engineering for quite a few mass timber buildings. Yeah.
That's great. And you mentioned that there's a lot of projects that you've been part of, essentially. So what are some of the systems, say, as you go from like the smaller buildings up, and as we scale higher, how are we actually doing a different mix of materials and different mix of solutions from the small scale, medium scale, and then higher scale?
Yeah, I think we have quite a lot of projects when we talk low to mid, so like up to 5-6 stories, lightwood frame walls with CLT floors is a really good system, and a really good entry point for people looking to get into mass timber who are maybe in the lightwood frame world before. And it works particularly well for residential because you have those lightwood frame walls anyway. If we're talking about office buildings, we're typically we've got beam and post construction is the most common, just looking for those longer spans, open spaces. And then as we go taller, definitely the beam and post construction and the point supported CLT are the two sort of most common construction types we're seeing. So that's sort of like, yeah, definitely as we go 12 stories and up from there.
Yeah. This might be a really basic question, but like in Australia, New Zealand, the light frame market doesn't really have that 3, 4, 5 story buildings. It's all concrete. So interested to know, what's the market share of just at the high level of like the light frame compared to concrete? How often does the light frame one come up with CLT floors?
I think the light wood frame is definitely really common. Light wood frame with CLT floors, maybe less so, but I think that would be just light wood frame in the market is probably just generally stronger, I'm guessing, than what you're seeing in Australia. I think a lot of the benefits we're seeing with the light wood frame is it's just really fast erection time, especially now we're seeing a lot of prefabricated walls coming in, and there's a few companies coming out now who are doing really great work in that like prefabrication of these light wood frame walls, and we're seeing a really quick construction time on site. But even I think, probably the light wood frame market in general is stronger here, I'm guessing. We still have concrete and steel, of course. Concrete would probably be more common. But yeah, I think it would definitely be the majority of the market share.
Yeah. Yeah. So no doubt, like some of the first projects that you've been part of, right? Like you go through things, there's scars, and then things you wish you learned along the way. And what are those things as an organization that you realize, like, these are the things that just have to be agenda items at the start? These are the things that the most important things that we've learned on these mass timber projects on our journey so far?
I think we've definitely learned that it's really important to have, ideally, if you can have like your supplier on board early, that helps a lot in developing kind of your schematic design, to develop an efficient schematic design. And it's also just really helpful to understand kind of their capabilities in their shop. And also the installer's input is really valuable to have throughout the design process, so that you can kind of hone down on what kind of connections they want to see, and what their sequencing is like. Yeah.
Yeah, and I guess to further what Meike said about suppliers and design, like for Tallwood 1, we actually had a supplier chosen the schematic design, so really early on, partially because there was limited suppliers available in the area at that time. There's much more now. So knowing exactly what their manufacturing capabilities are and what panels they have available meant that we could come up with a grid layout that really like maximizes the CLT in terms of efficiency. And especially with point supported CLT, where you see you have quite a close column grid center, being able to maximize that as much as possible really helps with the layout. And then for a lot of our projects now, what we're trying to do is have an early tender if possible. So bringing that tender day forward maybe at the end of sort of the design development phase. Because up to that point, we could have a design for multiple suppliers. Typically, we would look at North American suppliers, European suppliers, and have different options on our drawings for those suppliers. It's not really practical to bring that through later on in the project as we go get more detailed design. So yeah, end of DD phase, we'd have enough information on our drawings so that we could do an early tender just for the mass timber portion. And then when we go to the next stage of the design, we know who our supplier is, we can get them on board and just really hone in the design specific to what their products are and what their capabilities are.
Yeah, that's excellent, because that is something that keeps coming up on the podcast. It's like, choose the supplier early, but you want to keep competitive tension. So it seems like you have a really early process to actually choose a supplier to make sure they're on board and part of the team at the very start. Hey.
Yeah, and I think just for an example, like there's a Carry House project in Seattle, the 17-story, which is 12 stories mass timber on 5 of concrete. There we also have the builder on board, BM Builders, and having them on board really early means that when we go for this early tender, they can review all the tenders. They're really experienced in mass timber. They can see any scope gaps, allow for that, and like really able to draw a good comparison between, because it is an early tender still. We don't have a full detailed design. So having someone on board who, really knows the product and the market and what might be missing from different tenders so that we can compare them fairly, I think is, also really helpful.
Right. And how is the supply chain maturing at the moment? Do you see, are all the factories too full and the lead times are ridiculous, or is it a stage now where it's a right balance between a supply chain, a mature enough supply chain to actually deliver on what architects might be pushing at the start?
Yeah, it's a good question. I think it's been varying a lot. I think what's interesting with the supply chain is how different markets affect the pricing that's coming back. So for example, coming from Europe now, I think they're maybe a bit slower and maybe not at full capacity. So we're seeing pricing is really competitive coming back from there. I don't think we've seen any sort of major delays or people saying we have too much, that there's the market saturate, they're saturated and they can't produce, but certainly you're booking a slot of time, right? That's quite far out. So you are, booking that like months in advance for your project. And generally, I think it seems to be okay. We seem to be able to get those. And I guess the pricing would also be reflective of how much they're seeing coming in and how much they're going out. So,
yeah. Great. So looking at taller buildings, everyone gets super excited about like going taller. What are some of the design challenges as we get higher, and how can we start combining with concrete and steel in smart ways to actually enable more mass timber in higher buildings?
So I think in terms of combinations with steel and concrete, definitely for lateral systems, having steel or concrete lateral systems now for tall timber buildings is pretty much what we're seeing and the way forward generally. Trying to do lateral systems for taller mass timber buildings is difficult. I think we will see more of it in the future, maybe up to sort of 10 stories. I know there's a lot of testing for CLT shear walls up to 10 stories. So I think we'll see, some introduction in the code for that sort of thing. But for the moment, the CLT shear walls for lateral systems, it's quite restrictive in what you can do and how you design it. So not very common in taller buildings, or really possible. And then in terms of just the gravity system and combining those, I think for point supported CLT, sometimes we see steel columns used instead of glulam columns, which can be a nice alternative. Just in terms of the capacity and the size of the columns that you're seeing, and just being able to fit those columns maybe within a demising wall, as opposed to having a glulam column, which might be slightly larger than what your demising wall is. And then again, we are seeing some, like the delta beam, for example, again, another hybrid system to allow for long spans. If you want to open up the space a bit more than what maybe your traditional beam post might offer, or if you're trying to avoid those down beams in your beam and post solution.
One of the
question. I might have gone off point there a little bit.
That's it. Yeah. One of the most important things to, in projects that seems to be come up a bit is obviously cost. Everyone cares about cost, and that's always linked to speed of construction as well, to actually claw it back. So, and you might have already touched on this, but how can design program be optimized as much as possible for everything to just get that cost? Because I guess if it's the triple bottom line, sustainability tick, human health and biophilia tick, and get that third one on cost as reasonable as possible, then things start to become a no-brainer. Hey?
Yeah, and I think cost is obviously a big thing. I think one thing is just seeing if we can let like the structure sort of lead the design and how much the architect is willing to do that. So can we come up with a grid layout that really suits mass timber and is designed to suit mass timber? Can it be a very regular grid layout? Can we sort of come up with some key details that then get repeated throughout the project, just to make it a really efficient and economic design? That's really important. I think, again, having that from the offset rather than having a building which maybe it was designed for steel or concrete first and trying to switch to mass timber, but that grid just doesn't really suit what the mass timber wants to do. I know in Tallwood 1, we had a very regular grid, and the architect, it was like a 3 by 3.6, and we repeated that grid across the whole floor plate. And the architect was able to work with those columns and just made it work with their internal layout. So that allowed that structure to be really efficient. And I think in the end, when they did a cost comparison on that project for the mass timber versus the concrete, it actually came out pretty much equivalent. And we didn't really see a price premium for using mass timber there.
Yeah.
But I think the speed of erection is another really good point, because that's something that we often hear when we're talking about like cost savings going with the mass timber scheme. And it's interesting because I think when we look at a concrete, it's obviously a longer time for a concrete building to be constructed. And what we found at Tallwood, it was actually trying to get the rest of the trades to keep up with the speed of construction of the mass timber. And particularly, we had one issue. It was because it was during COVID, there was some procurement issues with the exterior walls, which were meant to come in. So we actually had to stop construction, waiting for those walls to come in, which slowed down the construction there, which was unfortunate, because I think it could have been a much faster timeline than what we actually saw. But yeah, I think it's important that the builder knows that from the offset, and they're able to keep up with the speed of construction of the mass timber.
Yeah, I think a key point is to design a mass timber building, assuming that you will be designing a mass timber building from the very get-go. So if you can like optimize your grid sizes based on using mass timber right from the beginning, you'll be able to design a much more efficient building. I mean, anything is possible for mass timber. We see things like timber concrete composite, but which can be a great system for achieving really long spans and things like that. But in terms of speed of erection, a lot of the time that can be a hindrance, because you would need to wait for the concrete to be poured at certain stages of the project to kind of gain stability and strength throughout construction. And so the mass timber installation team oftentimes doesn't want to wait for that additional trade to come on site. So if you can avoid that, it really pays dividends on your speed of erection and your costing.
Yeah, that's great. And Mike, what do you see as the future of timber construction? And maybe we can have a few threads there, and maybe we'll start on like a technology. Have you got thoughts on technology? There's you probably saw like ChatGPT last week, and there's all these things coming out in AI. You've got robotics, you've got parametric design, grasshopper, all these sorts of things. So what on the technology front, do you have any thoughts on how this might be used by designers and change our processes?
It's a loaded question, but I mean, I think
it is for sure.
Yeah, for sure. We've had conversations about this in the past, and we've had some people in recently into our office speaking about some of these tools that they're developing. So, I mean, it'll be great to see more softwares come out to quickly design, like to do the schematic design stage of a building, like sizing members and things like that. Like it's not rocket science. So if you can if we can get more tools that will enable us to do that kind of work quicker, we can kind of focus on the challenging bits of designing the structure. And also just in terms of codes and things, like there's a lot of different codes that we're referring to currently. Obviously, most knowledge in mass timber construction is currently coming out of kind of Central Europe. So if things aren't codified yet in North America, we kind of have to lean onto these codes. So I think the future of mass timber will kind of depend on unifying the approaches. Yeah.
Yeah, I think the same. Like even internally, we're looking at ways, how do we stop repetitive design and come up with clever ways to leverage on this technology that's becoming available to do the design and also produce our drawings. So it's not as manual. I think in terms of code, kind of pulling off what Mike has said, I mean, mass timber is still a relatively new material in the construction world when compared to steel and concrete. So I think we're going to see a lot more of the kind of like pre-engineered connectors, which are already really popular, but more of that as opposed to like the custom steel hangers. I think we'll see, I touched on this briefly earlier, but the CLT shear wall design is currently very prescriptive and quite limiting in what you can do. So I think we'll see a lot in that advance over the next few years and probably become more popular in use. One thing we don't cover very well currently in North America is design of robustness in mass timber buildings. It's covered very well in the Eurocode with various different methods like notional element removal or like tying forces, providing vertical and horizontal ties. So I think it would be great to see that introduced into the code here in some way, and probably something we'll see in the future. And also things like point-supported CLT currently isn't codified. And again, I know there's a lot of testing going on around that. So I think that's another thing we'll see come in.
Yeah, it's definitely an exciting future. It's been incredible to speak to both of you, Meike and Ornagh. If people want to find out more about both of you and get in touch about any projects they might have in the pipeline, how should they reach out?
Definitely reach out to us on, I mean, we're both on LinkedIn. You can reach out to us there, or just email our office and it'll get passed on.